Hey, let's talk about how you go about solving a dihybrid cross with this example from this worksheet. So one of the first things to remember is that regardless of whether it's a mono or dihybrid cross, no matter how many squares, first thing to do when making one of these is to make a key. So let's make a key regarding these traits. And then what will happen after the key is we'll set it for the thing, and then we'll figure out the Punnett square, and then we'll come back and answer all the questions at the end. So to begin with, the key. It says red eyes is dominant to brown eyes. So let's start with that. Red eyes is dominant to brown eyes. So I'll put red eyes and brown eyes. And then what's the other one? Normal spines is dominant to spineless. So normal spines. This refers to little hair-like spines that cover the body of a fly. Not the backbone, because flies are invertebrates, they don't have backbones. At any rate, next thing, once we got this all set, what does it say now to allow us to set it up? So here it said what's dominant, what's recessive. Next it says the parents are heterozygous for both traits. Ah, that's nice. Hetero, different. So heterozygous for both traits means that when it comes to having red eyes, yes, they have it, but they have one allele for each. And they also have both the spine and the spineless alleles of the gene for whether or not they have spines. So that means both parents being fully heterozygous means this mixture of dominant and recessive alleles. Now when it says the mom's possible gametes, here's the thing. When you set the Punnett square, you don't put all 4 letters in there. If it was one letter at a time, you'd put either a capital R or a lowercase r, which is to say showing one allele at a time. If it's 2 alleles, same thing, one copy of each gene at a time, so it'd be one of the R's and one of the N's. So if the mom's going to make babies, she's going to pass down one of every gene. So she's going to pass down one combination, or a combination of one of these alleles and one of these alleles. So what it's going to look like is either this R with this N, which is capital R, capital N, or if this capital R isn't with this one, it could be passed alongside this one, which would be capital R, lowercase n. Or what if instead of this one gets passed on? Well, it could be passed on with this one, so that's lowercase r, capital N is how you'd write that. Or it could be passed on with this one, so it's lowercase r, lowercase n. Make that clearly an R. And then the next thing is to realize that if the dad has the same genes, it's going to be the same thing. This R with this N, or instead of with this N, this R could go with this N, capital R, lowercase n. Or if instead of this one, you pass down this one, well, I could go with this one, R, N, lowercase r, capital N. Or it could be, what if instead of these two, it was these two? Essentially, this is just all the ways to pass down one of the R alleles and one of the N alleles, which is to say the eye color and the spine or no spine alleles. So being that this is all the possible way to pass down one of each, we now put these on the outside. So capital R, capital N, capital R, lowercase n, lowercase r, capital N, lowercase r, lowercase n, oops, n. Okay, so essentially I just put these here. The other parent would go on the other side. Luckily for us, it's the same. And that's what this is. I just realized that's off camera, so now we got that on camera and it's visible. It's just a matter of filling it in. And when you fill it in, capital R with this capital R, with this capital N, with this capital N. Or in this case, this R, this R, this N, and this N. Or this capital R, and this lowercase r, and this capital N, and this capital N, or this capital R, this lowercase r, this capital N, this lowercase n. And you fill it in using that pattern. So you just go through making sure that if there's an uppercase and a lowercase mix, you just put the uppercase letter first, and you fill it all in properly. And so on. And there it is, all filled out. So once that's done, we can now figure out what fraction out of the 16 possible offspring are going to have each trait. And we could go through all the possible combinations of traits, but let's just stick to answering the questions asked by up here. So it says, what fractions have red eyes and normal spines? We got to remember that red eyes is dominant, so is normal. So what it's really saying is what fraction have at least one dominant R and one dominant N? So those do. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 16 have at least one dominant eye color gene allele and one dominant spine allele. So we just put the answer 9 out of 16. And then we do the same kind of thing for brown eyes and spineless. So we look at brown eyes, we see that that's a recessive allele. Spineless is also a recessive allele. So in other words, it has to have 2 recessive alleles, 2 of these and 2 of these recessive alleles. All recessive. Well, there's only this one is the only one that has all recessive, which is why I know we can answer that as 1 out of 16. So with that, the next thing is to take this and go to the next step of, well, just answering this question here. Though before I do that, had I asked any others, say red eyes and spineless, or brown eyes and normal spines, you could follow that same idea to figure out what fraction is for each of those. But at any rate, why is it a bad idea to choose the letter S for spines and spineless? So why use the letter N instead of S? Well, don't forget, capital S looks enough like lowercase s that especially once you're in a rush, they all start looking the same. For that reason, keep it simple. Use letters that where the uppercase looks different from lowercase. Why is it a bad idea? Because uppercase looks like lowercase. And that's how you generally go about answering these.